Diesel engines, as an efficient, economical, and durable power source, are widely used in the industrial and agricultural sectors. With increasingly stringent environmental requirements, the research and development of clean diesel technology have become an important trend in the industry's development. This lesson will elaborate on the working principle and process of diesel engines to better understand and master the basic knowledge of this important power equipment. First, let's understand what a diesel engine is. A diesel engine is a type of internal combustion engine that injects diesel into the cylinder to mix with air, converting the heat energy from combustion into mechanical energy. That is, it relies on the expansion of combustion gases during fuel combustion to push the piston in linear motion, rotating the crankshaft through the crankshaft and connecting rod mechanism, thereby outputting mechanical work. Based on the different fuels used, internal combustion engines are divided into gasoline engines, diesel engines, and liquefied gas engines. They are widely used in automobiles, ships, generator sets, and other fields. The engines of domestic tractors are almost all diesel engines. Next, let's look at the types of diesel engines, which are divided into the following 4 categories. 1. Light-duty diesel engines refer to diesel engines with smaller power, usually used in small vehicles, agricultural machinery, generator sets, and other fields. 2. Heavy-duty diesel engines refer to diesel engines with larger power, usually used in large vehicles, ships, industrial equipment, and other fields. 3. Marine diesel engines refer to diesel engines specifically used for ship propulsion. 4. Automotive diesel engines refer to diesel engines specifically used for vehicle propulsion. Next, let's understand the basic structure of a diesel engine. A diesel engine is mainly composed of the engine block, crankshaft and connecting rod mechanism, valve train, fuel supply system, lubrication system, cooling system, starting system, etc., where the engine block is the foundational component of the diesel engine, bearing the main structure and functions of the engine. The crankshaft and connecting rod mechanism is responsible for converting the reciprocating motion of the piston into the rotary motion of the crankshaft, thereby outputting power. The valve train is responsible for controlling the opening and closing of the intake and exhaust valves to ensure the normal operation of the engine. The fuel supply system is responsible for providing the fuel needed for combustion work to the engine. The lubrication system is responsible for providing a lubricating environment to reduce mechanical wear. The cooling system is responsible for taking away and dissipating heat, maintaining the appropriate operating temperature of the engine. The starting system is responsible for making the engine transition from a stationary state to an autonomous working state. Now, let's explore the basic knowledge about diesel engines. 1. Top dead center, TDC. The point where the piston is furthest from the crankshaft's rotation center. 2. Bottom dead center, BDC. The point where the piston is closest to the crankshaft's rotation center. 3. Stroke. The distance between the top and bottom dead centers. 4. Cylinder. The process in which the piston moves from one dead center to the other and back again. 5. Swept volume. The volume of space in which the piston moves up and down. 6. Engine displacement. The sum of the swept volumes of all cylinders. 7. Four-stroke cycle. A. Intake stroke. B. Expansion stroke. C. Compression stroke. D. Exhaust stroke. 3. Working principle, process, of a diesel engine. Simply put, a diesel engine works by compressing air in a sealed space to generate high heat. When atomized diesel is injected and burns, it expands, pushing the piston downward along the cylinder. Through the crankshaft and connecting rod mechanism, which includes the piston pin, connecting rod, and crankshaft, the linear motion of the piston is converted into the rotary motion of the crankshaft. The inertia of the flywheel drives the piston to cycle through exhaust, intake, and compression movements, thus outputting mechanical work. The specific process is as follows. 1. Intake process. During the downward movement of the piston, the intake valve opens, allowing fresh air to enter the cylinder through the intake duct. At this time, the exhaust valve is closed to prevent the backflow of exhaust gases. 2. Compression process. As the piston moves upward, it compresses the air inside the cylinder, gradually increasing its temperature and pressure. At this time, both the intake and exhaust valves are closed to ensure that the air inside the cylinder is fully compressed. 3. Fuel injection and combustion process. Near the end of the compression stroke, the injector sprays high-pressure diesel into the combustion chamber. Since the temperature inside the cylinder is already sufficiently high at this point, the diesel ignites rapidly and produces high-temperature, high-pressure gases, releasing a large amount of energy. This force pushes the piston downward and, through the connecting rod and crankshaft, converts the piston's linear motion into rotary motion, outputting power to drive the vehicle or machinery. 4. Exhaust process. As the piston continues to move upward, the exhaust valve opens, and the exhaust gases produced during the combustion process are expelled from the cylinder during the piston's upward movement. At this time, the intake valve remains closed to prevent fresh air from entering the cylinder. By repeating the same work cycle, continuously performing work externally, diesel engines achieve continuous power output. Compared to gasoline engines, diesel engines have the following significant characteristics. 1. High thermal efficiency. Capable of outputting greater power and torque. 2. Better economy. Diesel engines have better economic performance over long-term use. 3. Strong durability. The structure of diesel engines is relatively simple, with a longer service life and higher reliability. As an important power device, the working principle and process of a diesel engine involve multiple complex mechanisms and systems. Through the explanation in this lesson, we can gain a deeper understanding of the working principles and characteristics of diesel engines, providing a theoretical basis for their optimization and improvement in practical applications. Finally, please consider the following 3 questions. 1. What is an internal combustion engine? 2. What are the basic components of a diesel engine? 3. Briefly describe the working principle of a diesel engine. This concludes our lesson for today. Goodbye, everyone.